Okay, so we're just looking at two different graphs, and it's going to ask, I guess, domain range about them. So part A is just what is, I guess for part A, the domain is what? So that's a line, right? So that means it's going forever in both directions. Well, it looks like it's going up and down. Since it's diagonal, it's also going left and right. So that means every x will be covered. The domain is all real numbers. How do we input all real numbers? Well, again, the answer there is asking for an interval notation. So when it's an interval notation and it's all real numbers and it's going forever in both directions, it'll be negative infinity on the left and then positive infinity on the right. That's how you're going to input a domain or a range of all real numbers in interval notation. It's negative infinity on one side, and then why did that disappear? Weird. Let's type in real quick again. Let's try that again. The range for that line, it's going up forever, it's going down forever. So the range is also all real numbers. So it would be negative infinity and infinity. Okay, on that. On what interval is the function decreasing? Well, increasing and decreasing is talking about whether it's going up or down. So this is decreasing the entire time. Since it's decreasing the entire time, the interval on which it's decreasing is all real numbers. So again, negative infinity and then infinity. Again, decreasing is just talking about, at what point of the function is it going down? Well, it's the entire thing. On what interval is the function increasing? Again, it's going down the entire time, so it's not increasing ever, so the function is never increasing. On what interval is the function constant? It is not ever constant. It is constant. It is decreasing the entire time, so the function is never constant is our answer there. All right, for part B, domain. It's going up forever in both directions, but while it's going up on this side, it's also going to the left. While it's going up on this side, it's also going to the right. So its domain is all real numbers. Its range is, well, it starts at -4 and it opens up. So -4 is the bottom, so that'll be the left side of the interval for a range. And it goes up forever, so then that will be to infinity. The right side would be infinity. It does cross through -4, so I'm going to put a bracket around that instead of parentheses. So it's -4 comma infinity, and then I'm going to end with parentheses because you would never put a bracket around the infinity. Okay. On what interval is the function increasing? So the function is going up from here all the way up here. But if it's talking about interval, we're talking about the x-coordinate of that point. That's 0. So from 0 to the right, the function's increasing. We're also not going to include 0, so we're going to use parentheses and not a bracket. The reason is because at that exact point, it's constant, meaning that's it. It's flat at the vertex. everything to the right of 0 is increasing. Where is the function decreasing? Well, the other side, right? Everything on the left all the way up until 0. So on the left side, it starts at negative infinity because forever it's decreasing until it gets to 0. So it starts with negative infinity all the way up to 0. All right, then on what interval is the function constant? Well, it's not that it's never constant, but it's constant technically at 0 at that point. That's not an interval, that's 1 point. So I'm going to say the function is never constant. Um, again, because it's just that one inflection point at the vertex. Okay, so it's not constant at an interval, it's just 1 point. Let me know if you have other questions.